In this presentation, we're going to talk about measurement. We're going to look at things like the logic of measurement, points to consider when choosing a measure, and resources for locating a good instrument for measurement. There are basically 4 steps to the logic of measurement. They include identifying a concept, selecting a variable representing that concept, choosing an instrument to measure the variable you selected, and then you need to determine the units of measurements for the variable in the instrument. Let's go over an example. In this example, our concept will be mental ability. The variable we want to look at is intelligence. So, intelligence is an aspect of mental ability. Then we're going to look at an instrument to measure intelligence. Here we're going to look at the GPA, grade point average, something you all should be very familiar with. Then we say, how can we specifically understand the units of measurement for the instrument? And that's when we decide to go with the 0 to 4.0. You could also do other things, but here we'll just go with 0 to 4.0, which is our unit of measurement for GPA, our instrument. And our instrument is how we measure the variable intelligence, which is how we understand the concept of mental ability. Some things to remember when choosing a measure. We want to think about what kind of measure we're looking for. What about multiple variable measures of the same concept? Multiple item measures for a concept. We want to look at instrument validity and instrument reliability, and to make sure we're looking at something with normative data. And we'll go over these a little bit more. First, let's look at what kind of measure we're going to be looking at. There are 3 types. We've got reactive, non-reactive, and psychophysiological. We'll go over each of these a little bit more. Reactive measure. This is when instruments are used to create and measure responses. We can look at examples like interviews, surveys, observations, things like that. Non-reactive measures include physical tracing and documents. Physical tracing is visible evidence of a behavior. So if we look at erosion, which is selective wear, or accretion, which is accumulation, so we can look at what's taken away or what's added to a situation or an observation. With documents and records, this is basically data that's already available through archives and other materials. Psychophysiological measures are when we assess the nervous systems of an individual or a group of individuals in a situation. So we look at blood pressure, heart rate, muscle tension, and more. A good tip is to use multiple variable measures of a similar or same concept. So choose multiple variables to measure the same concept. So here, we'll look at mental health, for example. We'll look at variables such as depression, anxiety, and happiness. So they're getting a better picture by measuring a variety of variables. Another tip is to choose multiple item measures. So from here, we can see that we've got 3 different things going on. We've got being prepared, having good communication skills, and maintaining a safe environment. We're asking somebody to rate these. And then we've given them a scale of 1 to 4, 1 being poor, 5 being excellent. So here we've asked them just to mark how they feel they perform in each one, for example. So you have prepared as excellent, fair, or communications is fair, and maintain safe environment is good. So based on this, we've got a score of 9. So the scale is multiple questions measure 1 variable, and each question can have a different response and have different weights. So here, we're going to look at different weighting. So safety gets double the amount of weight here. So when we look at prepared, they scored themselves a 4. We gave it a normal weight, so our total is 4. Same goes with communications. It scored a 4. We're going to give it a single weight, and then we'll get a total of 4, right? So what happens if somebody scores their safety is only fair, which is 2, but it gets double the weight. So the subtotal is 4. So our actual total went up because of the weighting. And this is helpful in a variety of circumstances. We also want to make sure that our instrument that measures what it was intended to measure, so we have instrument validity. And we can look at this in two different approaches with construct validity and criterion validity. And we'll talk about those more. Construct validity. It's a subjective judgment that an instrument is adequate. So we can look at face validity. An individual decides if an instrument is a good fit or not. Then we can look at content validity, which is where a group of judges or experts deem the instrument is representative of what is being measured. So we can either have face validity, where one person decides if the instrument is good, or content validity, with a group of experts, so to speak, decide if it's good. Criterion validity is when the adequacy of the instrument is judged by comparing the instrument to some type of standard. And those standards are usually concurrent validity and predictive validity. Concurrent validity is where groups of people score differently as expected on a concept. So, for the love of nature, compare hikers to people who hate nature, and you should see a big difference. With predictive validity, it projects a future outcome or event. So high-risk takers are expected to engage in higher risk activities than non-risk takers. So if you're surveying both, you can expect different answers. We can also look at convergent validity and discriminant validity. Discriminant validity is where we can compare a previously validated instrument and that measures different variables. For example, we have 4 total measures, 2 of which measure indoor activity and 2 of which measure outdoor activity. So overall, we're looking at some similar stuff, but they're slightly different. Convergent validity is when we compare to previously validated instruments. So if somebody scores high on one specific instrument and we're measuring that same kind of concept but with a different instrument, we expect them also to score high. Let's go over a few examples here to kind of check ourselves. Face validity is considered an excellent measure of validity. And that's not true. We need other types of validity to make sure that we're getting where we need to be. Content validity is essentially the same as face validity, and we also know that's not true. Concurrent validity requires documenting 2 or more groups of people who score differently on a concept in expected ways. That's accurate. Comparing the results of summer camp applicants received on a suitability for the job ratings versus final ratings their supervisors gave at the end of the camp is an example of predicted validity. And this is true. So we look at something we thought would happen, and we look at what happened, and we found out it was true. If a group of park rangers who scored high on a previously documented valid test for assertiveness have low scores on a newly developed measure for shyness, the new test is considered to have convergent validity. And that's not true. We're looking at 2 different things. Or 2 different instruments, I should say. Now let's look at instrument reliability, which is going to establish the stability of the instrument. There are different ways to do this. We can look at inter-rater reliability. That's when 2 or more people say this is an agreement. We're in agreement that this is good and reliable as far as an instrument goes. The test-retest. So the scores on the same instrument administered at different times are comparable. So we have 2 different 2 different times we've used it, and the results are similar. The split half reliability. Scores on 2 versions of the same test are examined and are comparable. So we split the test in half and give it to 2 different people, or 2 different groups. Inter-item reliability. Items in an index measuring the same concept produce the same results. Let's look at an inter-rater reliability example. We're going to ask 10 people to serve as raters to judge if the dribbling ability of an individual is excellent, good, fair, or poor, or stinks. So we're asking them to rate the ability of the dribbling of the individual. The results came out, and 5 raters, or 5 people, judged it as excellent, good as far as dribbling. 4 said it was fair dribbling, and 1 person said it was poor or terrible dribbling. So based on these results, our inter-rater reliability is about 50%. Next, let's look at a reliability coefficient. And this is a measurement of the accuracy of a measuring instrument. And it can range from 0 to 1, where 1 is perfect reliability. So when we're using different approaches to look at reliability, we're going to have a different reliability correlation. So the integrated reliability, this is when the ratings of 2 or more judges correlate with each other. And we want a reliability correlation coefficient of 0.6 or better. The test-retest reliability, where scores on the same instrument administered at 2 different times correlate with each other. There, we want our reliability correlation to be 0.8 or better, so we're getting really high. And it's going to follow suit with a couple other ones with split half reliability and inner item consistency or inner item reliability. So we want each of those to look at a reliability correlation of 0.8 or better. Here's a good example I like to look at when we talk about validity and reliability. So for each target, let's talk about how it demonstrates validity and reliability. So our first target, we have 4 shots and they're all over the place. So our data we gathered are not valid or reliable. So we can move to the next one, and we've done a better job. We've got a grouping up in the top left of 4 marks in the same area. So because they're close together, we know that's reliable. It's just not valid because we're not hitting where we want to hit. We're not hitting the bullseye. Then we get a little bit better, and we've got a good grouping, and we've got them in the general area where we want to have them, so they're valid and reliable.